All right. I think we're live. Are we live? We'll do it live. Let's see. Refresh. Make sure that I've got everything set up properly. Are we in fact live? View my channel. It looks like we're live. Let's watch my own live stream to make sure that that is in fact the case. Okay. We're live. All right. Welcome back, everybody. Today, we are going to be working on, well, firstly, let's acknowledge the fact that I'm in a dorm room now because I just moved into Georgia Tech, as you can see with the title for this video. But anyways, in my long absence, some of y'all may remember that I was working on a game engine. Also, don't mind the headphones. Let me know if the audio works because I haven't unpacked my microphone just yet. Classes start tomorrow, which means perfect time to get some software work done. So where we were when we left off, right now I'm working on a game engine called Citron engine. The idea is, make an engine that I can write my own projects in because I don't want to use someone else's technology. It's just me being snobby. That's the word for it. But to kind of show what this engine entails, this is Citron engine. This is the game engine I've been working on. And so far, it's actually pretty cool. To break down some of the tech behind this, the engine is written in C++ and uses WebGPU. Yes, you heard me, WebGPU as the rendering backend. Now, here's the thing. WebGPU is traditionally used in the web browser. However, Google and Firefox both have a C++ implementation of WebGPU, and that is what I'm going to be using for this engine because basically it lets me write a Vulkan, DirectX, Metal, and OpenGL backend in one go. And if I want to add another backend for, I don't know, console support, maybe this works on Switch or something, I can do that fairly easily. Although I won't be doing that in the immediate term. But here's what most of the work has been so far. So the engine has a full saving functionality, full logging functionality. You can see everything here. A full asset system. Icons obviously aren't implemented, but this is a material file, and you can see like the material has some cool properties. For example, it references a shader. It's got some stuff about the asset type, and then the shader it references is default, which is here. And it's just a shader asset. There's no parameters to tune on that. That's what the material is for. We have meshes, and we have a full ECS system with scriptable components. I can add components, remove components from whatever I want. All of this is serialized, saved to a scene file. Right now, the saving is binary based. I would like to make it raw text in the future because that's easier for Git, and I would like some good Git support in this engine. But long story short, that is where we're at, and it's pretty cool. The engine is surprisingly functional, and what I've spent the past little bit getting working was scripting. There is scripting. C++ to be exact. You can write your own C++ components for the engine. So for example, the way this engine works, also something I should probably touch, this is a true ECS engine. This isn't an ECS system under the hood, but it looks kind of like Unity's game engine system. No, you will write code adhering to the ECS standard, which means you will write a component that does not have any functionality, and you will write systems that operate on those components. Or rather, you'll have an entity which contains components. Components are just structs of data, and then you'll have systems which operate on the entity. Long story short, that's how this works. And the way you can kind of see that playing out in the editor is we have entities here, obviously, and we have systems here. This test system is a C++ system written, let's see, using the scripting API. I will show you the script. So down here at the bottom of the project, let me zoom in and make it a little easier to see. This is the project directory. This is literally the project directory for this demo project I'm showing. The way scripting works in this engine is you write C++ scripts. So for example, as you can see, we have this test system. The way that test system is defined here in an external C++ script. This file right here, test.hvp. This test system actually does move the entity. If we play, the entity moves. And then we can go, and then you can also, use the editor in play mode So as you can see, I can pause it and then keep playing it. And then I can stop playing as well. And that'll move everything back to where it was before I started playing. So that works. But that's using the C++ scripting. Furthermore, you can write components. So for example, there's this test component. It's just an empty component with a name parameter, and it's defined in the C++ file, scripting. Now, the way this works is when you build, you press this button or you do Control B, and it takes the C++ scripts that the user wrote, and it compiles it using CMake into a DLL, this libscripts.dll. The engine then links dynamically to this DLL and calls a very specific function. Now, in your project, you have to implement this function. It is this function, register script types. In this function, this is where you tell Citron engine, hey, I've made these components, I've made these systems, I've written them in C++. There is a reflection system in Citron engine, which means, for those of you who don't know what reflection is a programming language's ability to be aware of itself. For example, in C#, there are ways you can find out how many members a class has or what functions a class contains. C++ doesn't have that. I can't take, oh, thank you, Safar. I can't take something like an object in C++, and there's no way for me to go in and see what members this object contains or any of that stuff. So I wrote my own. It's a little more manual than I would like it to be, and that's what you can see here. So that's the reason for that is how the editor is aware of the properties to expose. So for example, this test system has this speed scaler. As you can see in this register system, we wrote our test system here in scripting. Register types, well, we tell the engine, okay, I made this system and it's called test system. And within this system, it has a parameter that's a float and its name is speed scaler. And then you have to specify the offset. This is for memory stuff so that you can actually edit the member variable. And the same thing goes for components. If I make a component, you can see test component is just a struct with a name in it. And the way that works, I register that there's a component I defined called test component, and this component has a string parameter called name. And that is how the engine is aware of this. So if you want to see this in action, let's say I want to add more to this component. So that's the implementation. Let's say I want to add more to this component, test component. Let's give it an int. We'll say int age. All right. Now the way that works, all we have to do is say Citron ECS registry, register component member, test component. It is an int, and it is age and offset of test component age. And then if we go back to our project, Control B, build it. It'll take a second to actually compile the DLL. But once the DLL is compiled, I need to also probably move it to a separate thread because the engine hangs, and we got an error. Sometimes sometimes Windows locks the file, which is not fun. Let's see. Okay, yep, it works. So it builds, as you can see. And then the test component now has, let's go here, test component, now has two properties. It has a name and an age. And the editor is aware of that. Let me make this bigger so you can see. Test component has a name and an age. And I can actually edit this stuff. And then I can save it, close it, reopen the project, and that field will retain its data. Now I think I know why this crashed. It's probably because I had this field open in the editor when I recompiled the DLL, which means that's something I need to fix, actually. I need to change that. So current, what was it? Select entity. There should be, what we want to do is we want to unselect any currently selected entity. So on event, this would be in the inspector panel. And then inspector panel on event, if event, what if event e dot get, let's see, category, I think it is, get category flags and event category keyboard, if e dot, let's see, if e dot get event type is equal to key pressed event, e equals event equals key pressed event, e event. Let's see, if event dot get key code is equal to SDL k b, and event dot get mods and SDLK control. What we want to do is we want to say set currently, what is it? I think it's editor get editor context dot, what is this? There's a way we can set currently selected item null pointer. I think that's what we can do. Let me make sure that's correct. Yeah, yeah, we can. So what that'll do is it'll make it where we have nothing selected, which is good. Which should mean now if I'm editing something and then I press Control B, it doesn't crash the engine because it's not trying to read the DLL that's actively being unloaded and rebuilt, which is pretty important, I'd say. It's taken a second to build though. I have to say the Wi-Fi here is pretty good, which is fantastic. But yeah, so what I want to get done today, or at least what I want to be working on right now, is I want debug drawing. One of the things that took a minute to implement is this infinite grid. You'd be amazed how frustrating an infinite grid is to implement. And if I Control B, yep, unselects everything. That's perfect. That's fantastic. Control B. Okay, that's good. And then if we go into our old component and we remove age, and then we go to registered types and we remove age from here, and then we build, that shouldn't crash, I think. Actually, wait, it depends if this might still crash. It depends if the recompile is happening before. Yep, it crashes. It won't crash when I open it, but uh-oh. Save problem. Open project. Okay. Open scene. Okay. Seems to have worked. Let me replace the scene though, just because I don't want any sort of corrupt stuff. I do need to fix that in the future. Test system works. We're going to create a rocket, a mesh. We're going to give it, this shouldn't be something you can access. Okay, whatever. That's kind of not ideal, but whatever. m7.glb, materials. Okay, now we have a mesh. We're going to add entity camera. We're going to add a camera component and we're going to move it back here, and you can see what the camera sees here, which is pretty useful, I'd say. There we go. And then if we play, yep, everything works. All right, save, close. I do need to fix that. I think I know what the issue is, because this event is getting triggered after the actual build event. We don't want that, which is unfortunate. But I think that's because we're doing this SDLK. Where is it? I think it might be in here. SDLKB. Yep. There we go. That's the problem. It's being called after. Actually, we don't want that there. We want that here. And this should fix that issue. We also, when we open a project, that should also, let's see, open project. I think it's in here. Open project. Oh, wow, what's up, man? Let's see. I think the problem, editor context, project file, currently edited scene path, set active scene. Where I think the inspector shouldn't automatically do that. But anyway, let's see. This should work a little better now. Okay, I think that seems to work for now. And we'll put the test component on here. We'll build. Seems to work. Okay. And also SDL, if we build scripts, We'll have to come back to this at some point. For now, that's a hacky solution. But I do want I want debug rendering. And when we render draw, there's this method we have, render debug data. So in the main render method, one of the things I want, it's in this draw debug grid. We also want debug pass.draw debug render data. And then for that, it's the same stuff the scene takes. So draw render data, render object cache.render objects, and then draw frame uniforms. I think we have those somewhere. Or do we even need those? Draw. Let's see. What does this take in? Draw uniforms. Draw uniforms. Although, now that I'm thinking about it, this draw render data doesn't need draw uniforms, right? Context render resources manager. I don't think it does. But you know what? We'll get that sorted out. And what was it? Draw debug Georgia Tech. Yup, Georgia Tech. Go Yellow Jackets. It's a fun place to be, though. I'm super excited. Classes start tomorrow. Debug grid. It's here. Yes. Good luck with studies. Thanks, man. I think I'm gonna need it. I don't know how much I'll be able to actually do any sort of. Not that I did much live streaming to begin with, to be honest. But let's see. We need a pipeline. Or pipeline. Null pointer. And then we do need the frame bind group. That's important. I know. Bind group, and we also need the context, which I forgot about. Because we get the first shader, which should just take in the frame bind groups. And then for render, it's pretty much going to be the same as this draw render data, except the key difference is we're using a very specific shader that we have defined. Let me make sure of that. All right. So what should happen here is we should draw everything twice if we do it this way. Let's see. If we draw everything twice, yep, drawing everything twice, nothing should change. Wait a minute. Yep, look at that. Everything's being drawn twice, and it's white because I think of the shader. I think the shader we're using is weird, but that's okay. So we have our pipeline. We're getting that. For each render object, get pipeline. Let me think. Render object. Yeah, we don't want that. The only shader we're going to be using is. Let me think about this. The only shader we're going to be using is some sort of like flat shader. So I think this will be a built-in shader. One thing this engine also has is there's shaders that are like stuff that the user won't be able to edit. So like the wireframe shader used for debug drawing. I wrote a Python script that just takes the shader code, turns it into a C string, and puts it in a header file so I can directly reference it in the engine that way. And it's kind of like it compiles. Let's see, lighting pass. We don't want this. I think that's the deferred rendering lighting pass. What I need here is this. And the big difference in the wireframe. Hey, what's up, man? Let's see. The big difference here, it takes in all of this stuff. That's correct. And it will just spit out like a straight color. In fact, draw uniforms, model uniforms. I don't think we're going to have a transform associated with this because for debug drawing, we're probably going to use like draw lines. And the lines will be specified in world space, so you don't actually need any transform. We'll have struct debug uniforms. Actually, hold on. Everything will have the same color. Actually, hold on. Let me think about this. There's different ways. Maybe we just bake it into the vertex color. Maybe that's what we do. When you add a line, it's probably more efficient, honestly. Okay. So we don't need model uniforms. This will just be like this. And then we'll take the output color and the output to the G buffer, which we don't actually need a G buffer output. We're just going to say color. We're just going to spit out a color. We don't need a G buffer output. Yeah, and we don't need model.diffuse at all. Let's see. Color. How do we? Okay. I think that should work. We also don't need material uniforms at all. It's a very simple shader. And then we'll go back to our renderer and kind of reflect this, although I do think we need to build our engine resources here. Yeah, and as you can see, compiled shaders.cpp now contains a C string representing debug wireframe. Yep, which is nice because now I can write my shaders in a file with syntax highlighting and then access them in the engine in a way where it's not going to be like editable by the user. Technically, you could edit it, but I don't think anyone's that dedicated. Frame bind groups, and then we also want WGPU bind group. Draw bind group, yeah. Get bind groups, shader, bind group layout 1, that's correct. Now the thing is, the shader that we need here shouldn't come from the render objects, actually. Yeah, let's see, std shared pointer. I think we have this in the resources. There's a special shader we're using. Yeah, debug grid shader will have shader debug wireframe shader. Yep, and then, and I think it's init resources. We do that. We don't want that. We want debug wireframe shader, debug wireframe, and now we have access to that. So the way this will work in the renderer, we don't need this. We don't need the shader that's using. We'll say render what was it? Context.render resource.debug. Get debug grid shader. We don't need that. It's debug wireframe shader. And then in the renderer, we'll get debug wireframe shader. Wireframe shader. I'll get the bind group from there. It looks like syntax highlighting is still catching up there. I'll get that. This will be frame. Count.buffer, padding, draw uniforms. If I remember correctly, no, get draw uniform buffer, parent frame, render count buffer. Yeah, we don't need these at all. I don't know why I passed those in here, but we just don't need them. That was from earlier. Let's see, draw, debug, render, data. We don't need to give it draw uniforms. And then, so now we have our bind group set up. We don't need any of this. And the pipeline is actually really simple. The pipeline is just going to be context dot, what was it? Pipeline context dot render reason dot get pipeline. And then a pipeline key contains what? Dot shader equals context dot render dot get wireframe shader. And then what else did we use for these pipelines? Shader, color attachments, depth stencil. Yeah. Shader dot color attachments equals, where are we getting these color attachments from? Get color attachment formats. And where are we getting this? This is from renderer.hpp. Color attachments. Oh, color attachment format. Get color attachments, return params, dot color attachments. Color attachments is, wait a minute. These are just formats. Okay. Which, for our output, I don't think we need more than just like one of them. So I think it's just how do we do this for the debug grid? Because that also just has one output. Get color attachment formats. Okay, yeah. And then we'll say has depth stencil attachment. I think it's false. And then .col mode equals none. And we set pipeline. And that works. But we do not need to be doing that here. It goes here. Wait a minute. I just put these in the wrong place. We'll take this, copy this, put this here, save. That works. Now we don't need to do this here. Okay, I know this sounds terrible. Wait. Connecting my AirPods. Okay, AirPods are connected. Don't hear me. It's audible. AirPods, how bad is it? Can you all hear me now? Is there sound? Okay, long story short, I think OBS says there's audio now. Can you hear me now? Okay, fantastic. For context, what just happened, these headphones, they died. They ran out of battery. So I had to switch to AirPods, but it seems like the AirPods didn't work. So now you're just hearing the audio from the webcam, which has got to be terrible. But don't worry, the stream won't go on for too much longer. But long story short, what I've been working on is the debug rendering for my game engine, Citron engine. And it looks like we've got a bind group error. I'm betting bind group with layout 1. What bind groups are? 0, 1, draw uniforms. When we draw this, that bind group, draw uniform. I'm not totally working now. Fantastic. Bind group with index 1 is not compatible. Expected type has dynamic offset. Draw uniforms. See how the debug grid did the. That's draw uniform. That should be correct. Go into actual renderer. We did the exact same thing here though. We have the draw bind groups here. Oh, that's what I see. This is how you get the draw bind group. That should work. Leave. Wait a minute. Not setting it anymore though. Yeah, that's a problem. Let's bind 1. Say draw. Now that should get us something. And then we can have like a wireframe draw. This won't be like bounding boxes, I don't think. Okay, so it's doing something. It's doing something. Look at that. What is happening? What the? Okay, look at this. I didn't. It's kind of crazy. Oh, I know what the issue is. I think I know what the issue is. This looks a lot like the inside of the missile. This is the mesh the missile is using, but we're doing some sort of weird projection thing. Gotcha. Okay. So, draw uniforms projection. That's probably the issue. Because we're getting what? Getting all of this is texture view issue that when we draw the debug grid, we're doing some projection stuff. So let's go back to the draw debug. If draw debug, and somewhere here we're setting the be different. When we render draw data, that's what it. Quad output texture render pass bug pass params. That's got to be the issue. Oh, that is so weird. This draw debug grid, well, actually I know the issue, and it's really stupid. Because we're trying to just kind of render a wireframe, we aren't trying to render a wireframe. We're trying to just, so actually this is working exactly. Here's what's going on. We don't have any sort of model uniforms being uploaded. If you look over here in the default shader, the model uploads its transform, and obviously we do this. That works. The issue here is that the model doesn't give us its transform, so that makes sense why it's being drawn like this. We're inside of it, and we never can really, like, all of this stuff is just not, it's kind of backwards. This is the missile. Now, the cool thing is it seems to be having the shader or the for the plane, the infinite plane drawing on, which is actually kind of awesome. I love these kind of bugs in graphics. That being said, this is because I want to debug wireframes. So, okay, this is gonna take a little longer because now that I'm thinking about it, we're gonna need some sort of like buffer that you can load all of the lines you want to draw in a scene, and we just draw those here. So that would be its own mesh. Or we could have like a line mesh and then just like use instance drawing to draw the same mesh like a bunch of times. Really don't want to do that right now. I'm very on the hot, I'm tired. I don't necessarily feel like fixing the bug right now. I make a stream, but this is kind of neat. Let's see. Maybe we can do something. Maybe in the renderer, need some sort of way to add. I think it might be in like, we'll have like a vector of lines. Draw instant. Draw all of the line meshes will be world space. We can buffer. Okay. We need a class restaurant. We have a debug. We do have a debug. Okay. Debug line. Debug. I think we just need lines. And resources have lines. Vector. Debug. All right, we have a debug line. Click. Have a void add. Pretty easy on that front. Then render. Have to debug. Before we draw anything. Debug. Maybe that's like we'll draw like the selected entity. I don't think we'll do that. Draw debug data, probably. Bug. Render data for now. I think we'll just take this there. Bug. Gosh. Objects. And what we're going to need to do, we're going to have a buffer too. Probably also be housed in have a buffer debug line. Then before we draw, actually, maybe it'll be at the beginning of the frame. Now that I'm thinking. Long story short, what we're going to do. Just going to draw once. Set mesh. It takes in a mesh. Mesh should just be like a lot. Should be like a draw instant. Pass. Draw. Draw. Here and we'll Yep, that should work. We could have just done it all in one method, but I just want to draw debug render data. Here, set this mesh to just be like versus have. Now that I'm thinking about it, I don't know if we can do line, because we'll have to be using like transform data. Maybe it's better to just construct this all into mesh. That's better. So instead of that, say, it won't be a GPU buffer. Mesh. Debug lines. All right. Happen is we'll just say X source we'll have a get no autocomplete not correct right now. See how they back. Get debug lines. That's what we need. Oh, that should work. Now that means what we have to do is this should be like empty. And it's also going to be null pointer. So versus and we also should have like void struct line multi-mesh. That will do that's fine. Void we're gonna say if line size 0 the next thing we should also do is when we're actually bring on this draw debug say if or we could just say get that does us is begin frame. One of the things we're going to want to do probably construct that. That will be that we'll just build a mesh from all of the vertices we've uploaded to that list. Everything should be working normally now. Yep, that looks normal. Good stuff. Draw like what? Although I'm kind of suspicious. This debug wireframe thing seems to just what did the grid spit out? Forward output. Yeah. You probably follow this convention. Follow the output. The input color. That should work. Ooh. Renderer, frame, construct. We're gonna add like a couple say here is add line debug line 3. We're gonna go from 0 negative 10 by 0 to 10. That should give. Obviously, we haven't implemented the actual function. So, for line, debug line. First thing we need to do is say debug time max. How do we make? It's been so long since asset create asset. I don't want this to be an asset at all. Actually, that's not what we're gonna do. Be paired. I want to see if there's actually a method. Vertices. That's what we're gonna do. Okay. UID. We'll say takes in vertices, indices, vertices. I'll probably make like a vector text for these. Bounds in, bound space, max, twice. We do need that, don't we? Have access to twice. Inbound. We have our debug line. Now here we need to take back. Dot position equals line. Let's start. Dot color. Honestly, lines should definitely have a color. Color. That should affected. Why is this not designated? Oh. Whatever. Just line art. Excellent. That should fix those issues. Text.color equals line color. And we also need to push back the indices. Oh, and we also need if start. Let's see. Start less than. Oh, we can't. I don't necessarily like the order that this was done. Start. Not necessarily the start. You know what? We'll just leave. We don't really care about the start and bound, but we need to leave. Bounding box logic does not work. We need to redo that later. Let's see. Very nice if it just worked off the bat. Oh, and the lines will also probably be black if we debug line color. See if this works. Not seeing anything drawn. Not the most promising. Maybe there's an issue with... Oh. Add a debug line. Mesh. Work. The problem is, oh, this is super inefficient because we're rebuilding the mesh, allocating stuff on the heap every frame. That's it. I may come back to this in a bit, to be honest. Can y'all hear some honking outside like crazy? Someone's losing it. Okay, it's so hot. Okay. I think I'm just gonna end the stream here because my AC is off and I'm starting to sweat in my. I don't want that, and this guy won't stop honking. I don't want y'all. So you can kind of see where I'm going with this. Just gonna probably bash all the lines. I can just draw one time. That'll be deep. And then if you want to draw like a capsule or a cube, it'll just be some placeholder functions that automatically add vertices. That's it, I'd say, for now. And I will see y'all later.